Let's do an application of our vectors. Suppose we actually have a 100 kilogram weight suspended from the ceiling as I've drawn here. So if we know that gravity is equal to 9 squared, what is the tension in each cable? So how would we begin to solve this? So the solution would be let T1 be a vector as well as T2 be a vector. And we'll denote these to be the tension in each of our wires that we have here. T1, T2. Okay. So let's let W be the weight vector. The weight vector of, oh, that's it. Let's let W be the weight vector of this mass here. Then W should just be equal to 0, because it's not moving left or right, and negative mass times gravity. Or in other words, it is equal to 0 and then negative 980. By Newton's third law, we know that if this is stable, that the sum of T1 and T2 and W must equal 0, since the weight is not moving at all. Correct? So we have our components that we have, remember, T1 will be equal to, we could say, T1A and T1B, and T2 is T2A and T2B. So we know that the sum of W, T1, and T2 should equal 0. But if we just tried to add it all component-wise, we would have 4 unknowns here. So let's think about this slightly differently. Remember from our two-dimensional problem that we just did that we had that the V going to be equal to the magnitude of V cosine of theta I plus the magnitude of V sine of theta j hat. So this is that ith component, this is that jth component. So what we need to look at is therefore the magnitude of the I component plus the magnitude of the I component of all 3 of them needs to be equal to 0. So in other words, we're going to have that the magnitude of T1 cosine of 120 degrees plus the magnitude of T2 plus the cosine of 30 degrees plus 0 equals 0. And where the 120 comes from is we have the 30, which this is now our positive x-axis. So remember, because we have pull in this direction, we actually have to use the 90 degrees plus the 30 degrees for this T1 value, getting our 120. So similarly, we also know the magnitude of T1 sine of 120 degrees plus the magnitude of T2 cosine of 120 degrees plus all our negative 980, that also needs to equal 0. Then, when we simplify this, we will just see that the square root of 3 times the magnitude of T2 is just going to be equal to the magnitude of T1. And then the square root of 3 magnitude of T1 plus the magnitude of T2 should equal 1,960. If we plug our values in like we should, then we are going to just get that 3 magnitude of T2 plus magnitude of T2 equals 1,960, which simplifies into 4 magnitude of T2 equals 1,960. And when we divide that, we get the magnitude of T2 is just going to be equal to 490. And then from here, we have that the magnitude of T1 should be 490 times the square root of 3. And then we figured out the tension for both of our chords that we have.